Good morning, guys. Today we are going to the new chapter, chapter 2, motion with constant acceleration. Okay, please open your textbook about page 14 and 15. Okay. And let's have a revision about chapter 1. It's mind talking. Okay, we have in chapter 1, we have talked about the physics unit, the temperature of the unit, the length of unit, and blah 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 of unit. Today, in chapter 2, we are going to concentrate about the motion. We also can say it's an action. In this action, what physics units that involve? Okay, and we're going to introduce a brand new unit in this motion. Okay, so sorry. Let us start from a story. Okay, we can see as Mickey Mouse have a jogging in a park. Okay, he has a constant speed of 10 meters per second, jogging in the park. Okay, after a few seconds, Mickey Mouse found that there's a dog chasing him. So Mickey Mouse ran fast, and the Mickey Mouse ran. The speed is higher than before, become 50 meters per second. So in this action, or we can say in this motion, what units of physics can you see? Well, anyone? Yes, you can see speed, time, distance, and acceleration. So today, we are going to introduce the acceleration that we haven't speak or haven't introduced before in chapter 1. Okay. So in this lesson, you all should be able to explain what is acceleration and judge the function of acceleration. And you all should also be able to use all motion units to understand the forms and how it works in the formulas. Okay. So we have learned a lot of the physics units. This in the motion, we use these units to explain and work in physics. Okay, in this motion. First is initial speed. The second is final speed, acceleration, the distance covered, the time taken. Okay, I believe that the front of these two and the last of these two you all should already know because it's very simple. And what is acceleration? Acceleration is per time or per second at the or decreased speed. Or we can say every time the previous velocity of the object change. If this acceleration, if the man ran a different angle, also the acceleration will be changed. And we present this acceleration as a. And the unit of it, we can say, is a meter per second square. Okay. This is a more further explained on acceleration. As we can see, the velocity is distance divided by time. Then this acceleration is velocity divided by time. It means the velocity change in per time, added or decreased. So here's an example. There is two guys. One is the red man with a red head, and one is the white head. So imagine if you are a red man standing on the escalator. As you can see, this escalator is pushing this red man up. But this red man can't realize he's going up unless he observes his surrounding that, oh, I'm going forward, so I'm changing my speed, I'm going up. So this brakeman can't realize that he has a speed going up unless his surrounding, seeing the surrounding of himself was changed. So this brakeman, for example, he going up in this brake arrow, okay, in this brake arrow going up. So we can see there is a speed on him. So he think that he didn't have acceleration. He only got the speed on himself going up. Now imagine you are the white guy who is standing over here. When this brakeman you observe it didn't move, we can observe that this brakeman is going up as the green arrow show is the speed of it. Without acceleration is an internal speed. Okay, the speed didn't added or decreased. But if this brakeman going up, by the meantime of the escalator also pushing him up, we can see there is two speed over here. One is the red arrow, one is the green arrow, as this white man can observe on this brakeman. So as the angle of the white man, we can see as the green arrow is the velocity and the red arrow is the acceleration that added in this motion. Okay, is a video we can look more further and clear. Share it.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed. Velocity changes as the direction changes.
Okay, we'll watch until here. So let's continue our class. Okay. So here's the formula of this motion. V minus u equals to a times t. So let's have a look at the first part. Part 1, v minus u. Today we found that this v is different from u as the previous video we have seen. The velocity is changed. So we use this v minus u to find the speed, or we can say the velocity that been added or decreased. For example, 50 meters per second is the start speed. It decreased until the 30 meters per second. So the speed is decreased 20 meters per second. Example 2, as the started speed is 20 meters per second, but it added until 70 meters per second. So the speed has added 50 meters per second. This means that in part 2, you can see this is acceleration times the time. So this speed that we added or decreased is equal to the per second of the acceleration. So we can say in another word, if the speed didn't change, that means the acceleration is 0. Okay? If the speed didn't change, that means the acceleration is 0. So let us move on into this example. If a car speed up from 30 meters per second to 70 meters per second with 5 seconds, what is the acceleration of this car? To solve this question, first of all, we need to write down the data that was given. So, in our introduction in this motion, we have internal speed, initial speed, final speed, time taken, and acceleration. These 4 things. Okay, and distance, but today we will ignore this distance. Okay, we will just focus on these 4 units. Okay, initial speed, final speed, time taken, and acceleration. Okay, so as we write down this data, now we are going to write the formula. The formula is v minus u equals to a times t. Yeah, we have previous slide we have talked about it. Just copy and paste. And the third step is put in the number. So the v is 70 meters per second, we put in. The initial speed is 30 meters per second, we put in. And time taken is 5 seconds. And we are going to find acceleration. So putting in after calculations, easy calculation, and we get the acceleration of this question is 8 meters per second square. And in the last, please write the acceleration of this car is 8 meters per second square. We must write this answer conclusion below this equation. Okay, please remember this. So, can you guys I give you about 3 minutes. Please solve this question with these 3 steps. Write down the data, formula, and put in the number. Okay. Alright, guys. We have come into this question. Let us solve it. Okay. Who can tell me what is the initial speed? Yes, Derek. Great, 70 meters per second. And what is the final speed? Yes, 40 meters per second. Got it. Yeah, Michelle, great job. And time taken is 3 seconds. Right, go. And we are going to find out the acceleration. The formula, can you all type in the chat? Yes, yes. Great job, TJ. Great job. V minus U equal to A times T. So what is the, put into the number, and what is the answer? Anyone? Yes, there is a negative in this equation. So it is a negative 10 meter per second square. It means this acceleration is decreased. It's not at the speed, it's decreased the speed. Okay, so we write the answer as the acceleration of this car is negative 10 meter per second square. So if a car speed up from 1 meter per second to 150 meter per second with 6 seconds, the acceleration of this car is 4 meter per second square. What is y? So say, okay, we find the final speed acceleration time taken, but this is different a little bit because previously we are finding the acceleration. Now we are finding this initial speed. Okay, we are finding this initial speed. So, but the step is the same. We just repeat it, write down the data, and write down the formula, and put in the number. So this is the answer: 100 to 126 meters per second. Okay, it's all the same. But I hope that you guys can give me the answer. How is the equations calculated? Yes, yes. Great job. Great job, Max. Yes, that's the answer. Okay. So if you want to see the correct answer, you can see the Max answer is in the chat box over there. Great. So, okay, sorry. Okay, this time have a 3 minutes C in this question, and after 3 minutes we'll discuss about this question. Okay. Sorry. Okay, now let's look. Initial speed is 120 meter per second. Acceleration is -5 meter per second square. Time taken 3 seconds, and we are finding this final speed. Okay, the formula of this is V minus U equals to A times T. So when we put into the number will be, okay, great job. I see you guys, so many answers. Yes, the answer is 100, sorry, 105 meter per second. So now I will leave this question to you. Please follow the step 1, step 2, and step 3, and repeat it again and again. Okay. I have found some mistake that have given in this chat box is the unit. Okay, don't change the unit, just use it. Some of this question there will be kilometer per hour, but all of mine this question is meter per second. So you don't need to change it, this unit into km per hour. Okay, we all use meter per seconds. Okay, the seconds also we didn't need to change the unit because it's standard. Okay. So again, Step 1, write down the data. What is the given internal speed, final speed, time taken, acceleration. And step 2 formula, step 3 put in the number, and the acceleration is 9 meters per second square. So can you send me what is the details that how it's calculated? Yes, great job. Yeah, that's it. Actually, it's very simple. Just need to write down the data, remember the formula, and put in the number, and you will get the answer. Now let us see. If a car decreases the speed from 90 meters per second to 30 meters per second with Z, this S means seconds, how many time taken of this motion, and give the acceleration as negative 13 meters per second square. What is that? And we just put inside as the same. We repeat it again and again. Final speed, initial speed, acceleration, time taken. Always repeat it. Okay. I believe you guys can do it because you're secondary. Yeah, it's very simple. And same formula, put in the number, easy equation, minus and divided, easy. Yeah. So this is the last of this question. If a car moves from 40 meters per second to 40 meters per second speed with 3 seconds, what is the acceleration of this car? Now you have 3 minutes to solve this. Okay, welcome back. So the answer is 0, because the speed of them didn't change. The initial speed and the final speed didn't change. So you can repeat the 3 steps, but the at last of the answer is still will become 0. Okay, the acceleration will also become 0. So because we need us to do this. But if you see this 40 is 40, it didn't change. You can just write the 0, the answer. You didn't need to repeat the 3 steps. But it's okay to repeat the 3 steps, just wasting your time to doing this. Okay, so we have come to the conclusion. The conclusion is today we have learned the unit of acceleration, as we present it as A, and it is called velocity per second. Okay, and the unit of this is meter per second square. Okay, it's the same. So giving you task to think about this topic is, what is acceleration? And create an example to explain this acceleration. Okay, this is the task for you to think about what is acceleration, and please hand it tomorrow, okay, to me at your activity books. Please hand it to me. You can give. There is. How about? Yeah, let me check. Okay. Then great, Annabelle. Okay, great. So Annabelle will collect all the activity books and hand it to me in tomorrow. Okay. So please hand it your activity books to Annabelle about these 2 questions, and Annabelle will give me your activity books. And please hand it before 1 o'clock. Okay, before 1 o'clock, and Annabelle will hand it to me. So another, we can say, the formula is very, very important. If you mess up this formula, then everything is doomed. You didn't need to do any equation. You didn't to calculate anything because the formula is wrong. So today we just introduced 1 formula, but in this motion we got 4 formula. Okay, so it's combined a lot of these 5 units, but Today we just introduced 4 of it without using the S distance that cover. So in this formula, we want to seek that the change of the speed. Okay, and this change of the speed is equal to the change of acceleration time. Okay, please remember this. This is very important. Oh yeah, in the previous of the chart box IMC, a lot of people miss out V and U. Okay, the final speed will minus to the starter speed. Okay, so some of the people, you just put the initial speed minus the final speed is wrong. Okay, it's the final speed minus the initial speed. Okay, important things I repeat 3 times. The final speed minus the initial speed. The final speed minus the initial speed. The final speed minus the initial speed. Okay, so this is the last of this lesson, and please, I will send the slide to you, and please have a look and do it yourself, repeat and repeat, because what is about physics is just 3 steps like that. Write down, put in the data, write down the data, write the formula, and put in the data. 3 steps. Okay, write down the data, write down the formula, put the data into the formula. That's it. No matter what, how hard the physics question it is, the step is just repeated, and repeated. So today's lesson is very easy because the formula didn't change, and we just observe what the question gives from the data and just put in. So I believe you guys can get it because it's very easy, right? Only one formula, just put in the data. If there is another formula, then we should observe what formula is suitable to put in. Okay, so this is the end of this question of this lesson. Does anyone have any question about this? No, great. And record this so you can have a look and have revision. If you have any difficulties, you can also WhatsApp me or call me. And you can look on this recording to have a reminder or to refresh your mind what is acceleration and what's the formula works. Okay. So goodbye guys and have a nice day.